Okay, so this is the key to 16.1 part C, and here you want to use the square root property. So you have each of these are quadratic equations, because if you were to multiply this out, you would get x squared in each case. So these are quadratic equations, and you're asked to solve this using the square root property. Now the reason why it's easier to use the square root property here, because remember, whenever you have an expression squared equal a number, okay, a constant, then you can get that expression by itself by taking the square root of both sides. Okay? All right, so let's look at this. So I'm going to go ahead and rewrite this over, and I may need some room, so I may use another sheet of paper. But you have x minus 4 squared equals 16. All right, so I want to solve for x. All right, and I want to do that by using the square root property. But before I can use the square root property, I have to have it look just like this. Some expression squared equal a number, and I do. So I have some expression squared equal a number. So I'm going to take the square root of both sides, because the opposite of squaring is to square root. But you got to remember, when you took the square root of both sides, whenever you take the even root of both sides, you do the plus or minus. You get a plus or minus. So the square and the square root undo each other, so you're left with the radicand. So that's x minus 4 equal, and then plus or minus, and the square root of 16 is 4. Now at that point, remember, at that point is where we started talking about real numbers and imaginary numbers. This is a real number, and in fact it's a rational number. So since this is a rational number, so I'm going to get rational solutions here. Rational solutions. I'm going to break this down into two parts because I want to know what those rational solutions are. So you're going to say x minus 4 equals 4, positive 4, and then this will also equal a negative 4. All right, so x minus 4 equals a positive 4 and a negative 4. And then notice you went from a quadratic equation to two linear, so solve each one. So you get x to be 8, and then here you get x to be 0. Okay? All right, next one. So again, same idea. You're going to have x plus 5 squared equal negative 49. So you're going to take the square root of both sides. Just like that. Don't forget the minus underneath, plus or minus, right? Okay, so you're going to remember the square and the square root undo each other, so you're left with the radicand. X plus 5 equal plus or minus. Now, remember, this is square root of a negative 49. So square root of a negative 49 means the square root of a negative 1 times the square root of 49. And square root of negative 1 is I. Square root of 49 is 7, so this is 7i. So this is plus or minus 7i. Okay? All right, now since these are imaginary solutions, you can write your answer like I'm about to do. So just get x by itself, so you can subtract 5. Combine like terms, you get x equal negative 5 plus or minus 7i. And so that's your answer. Okay? If you want to write them as two separate solutions, you can. So you can say x equal negative 5 plus 7i, comma, x equal negative 5 minus 7i. Does not matter. Okay, number 3. So number 3, we again notice I have an expression squared equal number, so I can go directly to taking the square root of both sides. Okay, so I'm going to take the square root of both sides just like this. Don't forget plus or minus. The square and the square root undo each other, so you get this expression x minus 7 equal plus or minus the square root of a negative 24. Okay, now you want to simplify the radical. All right, so let's talk about the square root of a negative 24. I'm going to do that here. Let's go ahead and do that here. Square root of a negative 24. All right, so we know the square root of a negative 24 means the square root of a negative 1 to the square root of 24. I know that the square root of a negative 1 is I. And I know that I can simplify the square root of 24 because 4 goes into 24. So it'll be the square root of 4 times the square root of 6. Square root of 4 is 2. So you get I times 2, square root of 6. So that's 2I square root of 6. So that goes here. So that goes here. So it's the x minus 7 equals plus or minus 2I square root of 6. Now these are imaginary numbers because you have that I, imaginary numbers, imaginary solutions. All right, so I'm going to write it just like this. So all you got to do now is just get x by itself. So add 7 and you're done. Add 7 to both sides and you're done. So x equals 7 plus or minus 2i square root of 6. And there's your answer. Now if you want to write it as two separate solutions, you can. You can say x equals 7 plus 2i square root of 6, comma, 7 minus 2i square root of 6. Does not matter. Okay? All right, let's do number 4. Now number 4, you have an expression squared equal a number, so let's go ahead and take the square root of both sides. So I get 3x plus 2 squared equal 64. Take the square root of both sides, just like this, plus or minus. All right. The square and the square root undo each other. So you get 3x plus 2 equal plus or minus. Now the square root of 64 is 8. Now that's going to be just like number 1. See how I got 4 here and this is 8? So those are rational solutions. So these are rational solutions. So then I expect you to tell me what they are. All right, so you got to write them just like these. So you're going to say 3x plus 2 equal 8. So notice I went from a quadratic equation to 2 linear. I'm getting 2 linear equations. And then 3x plus 2 equals a negative 8. And then you just solve each linear equation. So I'm going to subtract 2 from both sides. So I get 3x equal 6. Divide both sides by 3. I get x to be 2. So that's one of your rational solutions. The other one, subtract 2 from both sides. I get 3x to be a negative 10. Divide both sides by 3. I get x to be a negative 10 thirds. All right, so those are your 2 solutions. Your 2 rational solutions. Number 5. Okay, so number 5, again, I have an expression squared equal a number, so I'm going to go ahead and use the square root property. So I'm going to go ahead and rewrite this over. All right, so I'm going to take the square root of both sides. Remember, you take the square root of both sides, so we get that plus or minus. So the square and the square root into each other, so you're left with this expression. And then plus or minus the square root of a negative 25. Remember, the square root of a negative 25 means the square root of a negative 1 times the square root of 25. Square root of a negative 1 is defined to be I. Square root of 25 is 5, so that becomes plus or minus 5i. Again, notice these are imaginary solutions. Imaginary solutions. So then you're going to write it just like you did if you did these. Okay, just like these. All right, so you're going to add 3 to both sides. So you get 2x equal 3 plus or minus 5i. And then all you do is divide by 2 and you're done. Just like this. So x equals 3 plus or minus 5i divided by 2. So you left it in compact form. If you actually want to write the 2 separate solutions, you can. So you can say x equal 3 plus 5i divided by 2, all divided by 2, comma, 3 minus 5i, all divided by 2. Okay? All right, let's look at that one. Number 6. So you have an expression squared equal a number, so I can go ahead and use the square root property. So I get 5x plus 3 squared equal 32. All right, now I'm going to take the square root of both sides, plus or minus. Don't forget that. Some students always forget the plus or minus. So you get, so the square and the square root undo each other, so you get 5x plus 3 equal plus or minus. Now let's talk about the square root of 32. So I can simplify that because 4 is a perfect square. I'm sorry, 16 is a perfect square that goes into 32. Now 4 goes into 32, but it's not the largest. Always use the largest. It makes things a lot easier for yourself. So the square root of 16 is 4, so you get 4 square root of 2. So that becomes 4 square root of 2. All right, so you must simplify your radicals. And then notice these are irrational solutions. Okay, irrational solutions. So you're going to write them just like you did. You're going to write your solutions just like you did your imaginary solutions. So these are irrational. So you're just going to, just like we did this one, you're going to subtract 3 from both sides. And so you get 5x equal 3, minus 3 rather, plus or minus 4 square root of 2. And then finally divide by 5 and you're done. So you get x equal negative 3 plus or minus 4 square root of 2, all divided by 5. Now if you want to rewrite them as 2 separate solutions, you can. So you'd say x equal negative 3 plus 4 square root of 2 over 5, comma, negative 3 minus 4 square root of 2 divided by 5. Okay? All right. And then finally, number 7, we have okay, so number 7, we have this. So we have an expression squared equal a negative 48. So I'm going to go ahead and rewrite this over. Take the square root of both sides, plus or minus. So the square and the square root undo each other. So you get 4x minus 1 equal plus or minus the square root of a negative 48, right? So let's talk about the square root of a negative 48. Let's do that here. So the square root of a negative 48. So the square root of a negative 48 I can write as the square root of a negative 1 times the square root of 48. The square root of a negative 1 is I, so these are going to be imaginary solutions. And the largest perfect square that goes into 48 is 16, so I can write that as square root of 16 times the square root of 3. So that's I times 4 square root of 3. So I can rewrite this as 4I square root of 3. That goes here. So it becomes 4x minus 1 equals plus or minus 4I square root of 3. Okay? And then just go ahead and write them in compact form. So I'm just going to add 1 to both sides since these are imaginary solutions. So I get 4x is 0. So I get 4x equal 1 plus or minus 4I square root of 3. Divide by 4. And I get x to be 1 plus or minus 4I square root of 3 divided by 4. Okay? So that's your solution if you want to. Now, don't make the mistake and reduce these 4's here. Don't do that because if you do that, you're forgetting about the fact that this is also being divided by 4. So don't do that. Leave it like that. Now, you can also write as two separate solutions. So you'd say 1 plus 4I square root of 3 divided by 4, comma, 1 minus 4I square root of 3 divided by 4. Okay? All right. So again, don't make the mistake. This is a mistake. Mistake would be to do this. 1 plus or minus 4I square root of 3 over 4. Where someone would do that. You cannot do that. That's a mistake because you're forgetting about the fact that 1 is also being divided by 4. So really you have this. You really have this. 1 over 4 plus or minus 4I square root of 3 over 4. So see, you have 1/4. Now if you wrote it as two separate fractions, then you could do this. All right, that's true. This is true. This is not true. Okay? All right. So just be on the safe side and just leave it like that. Don't try and reduce this little part here because you can't. So leave it alone. Okay, so that will be the key to worksheet 16.1, part C.